part of section 8.4, where we will continue our discussion on systems of nonlinear equations in two variables. We'd like to begin the second part by looking at solving a nonlinear system by the addition method. So let's use an example. So this will be our example 2. I started it in the part 1 video, but I'm going to start all over again in this part 2. So our example 2 says solve the system. We have 3x squared plus 2y squared is equal to 35. We have 4x squared plus 3y squared is equal to 48. All right, so to solve this equation, we will attempt to find a means to either make the terms that involve x squared or the terms that involve y squared. We'll try to find a way to multiply either equation 1, let me call this our equation 1, our 3x squared plus 2y squared is equal to 35. Is our equation 1, and 4x squared plus 3y squared is equal to 48 is our equation 2. So we'll find a way to multiply equation 1 by a number such that, and equation 2 also by another number such that if we subtract one from the other, one of the terms, either the x squared term or the y squared term, whichever of them that we choose to focus on will go to 0. So for example, if we multiply equation 1 by 3, so that will give us, if we multiply equation 1 by 3, and multiply equation 2 by 2, that will give us, if we multiply equation 1 by 3, we'll have 9x squared plus 6y squared is equal to 105. Let's call this our equation 3. And if we multiply equation 2 by 2, we will have 8x squared plus 6y squared is equal to 96. Okay, so now if we subtract, let's call this equation 4. If we subtract equation 4 from equation 1, if we subtract equation 4 from equation 1, if we subtract equation 4 from equation 3, what we will have is 9x squared minus 8x squared is x squared. 6y squared minus 6y squared is 0. So this will be equal to 105 minus 96. So that will give us 9. So from here we see that x squared is equal to 9, which means x is equal to plus or minus square root of 9, which means x is equal to plus or minus 3. Okay, so when x is equal to 3, then we can substitute the value of x into either equation 1 or 2 to find the value of y. So if x is equal to 3, equation 1 is 3x squared plus 2y squared is equal to 35. So when x is equal to 3, then we have 3 times 3 squared plus 2y squared is equal to 35. So this becomes 3 times 3 squared is 9 plus 2y squared is equal to 35. And 3 times 9 is 27. So 27 plus 2y squared is equal to 35. If we subtract 27 on both sides, then we have 2y squared is equal to 35 minus 27, which is 8. And if we divide both sides by 2, we have y squared is equal to 4. And if y squared is equal to 4, that means y is equal to plus or minus square root of 4, which is equal to plus or minus 2. So that means the when x is equal to 3, the values of y are positive 2 and negative 2. So the solution set when x is equal to 3, we have the solution set. X is 3, y is 2. We also have x is 3 and y is negative 2. So this is the solution set when x is equal to 3. All right, so next let's look at when x is equal to negative 3. So when x is equal to negative 3, our equation again is equation 1 is 3x squared plus 2y squared is equal to 35. And so if we substitute x is equal to negative 3 into this, then we have 3 times negative 3 squared plus 2 times uh, 2 times y squared is equal to 35. And comes 3 times negative 3 squared is 9 plus 2y squared is equal to 35. So this is 3 times 9 is 27 plus 2y squared is equal to 35. So if you subtract 27 on both sides, we have 2y squared is equal to 8. And divide both sides by 2, divide both sides by 2. So we have y squared is equal to 4. So y is equal to plus or minus square root of 4, which equals to uh, plus or minus 2. So the solution set is the solution set when x is equal to positive 3, we have y is equal to 2 and y is equal to negative 2. So when it's equal to 3, we have 3 and 2, 3 and negative 2. And when x is equal to negative 3, we also have y equal to positive 2. And when x is equal to negative 3, we have another value of y equals to negative 2. So these become the solution sets of the system using the addition method. Next, let's look at an example that involves an application. Let's look at an application example. So we'll call this our example 3. So this is example 3. This is an application problem. So we have find the length and width, and the length and width of the rectangle, whose perimeter is 20 feet. Okay, whose perimeter is 20 feet, and whose area is 21 feet, is 21 square feet. All right, so we have an example where we are given some piece of information, and it says the length and width of a rectangle whose perimeter is 20 feet and whose area is 21 square feet. Now we have to find the length and width of a rectangle, and we are given the perimeter. Okay, so if we let's say if we let x be the length of the rectangle, so we say let x be the length of the rectangle, we let x be the length of the rectangle, and we say let y be the width of the rectangle. If we do this, then we are told the perimeter is 20 feet. So the perimeter is made up of twice the length plus twice the width. So the perimeter of a rectangle is um, the sum of all the sides, the sum of all the four sides. And so this is 2x plus 2y is equal to 20. And again, we are told the area is 21 square feet. So the area is the length times the width. So that is x times y. So we are told x times y is equal to 21 square feet. So we have these two equations, equation 1 and equation 2 to solve. As we are not told which method to use, so we can pick the method that we can pick here that would work easily for us would be the substitution method. So from equation 2, if we divide from equation 2, xy is equal to 21. If we divide both sides by x, then we have y is equal to 21 divided by x. So we can substitute this value of y into equation 1. And so that would become, if we substitute y is equal to 21 divided by x into equation 1, then we will have 2x plus 2y, and y now is 21 divided by x is equal to 20. And so this becomes 2x plus 42, 2 times 21, which is 42 divided by x is equal to 2. And from here, we can multiply x. X becomes the LCM. So we can multiply everything by x, or we can find the LCM on both sides. And so the LCM on the right here becomes x, and 2x is the same as x divided by is the same as 2x divided by 1. So 2x divided by 1, if the LCM is x, then 2x becomes 2. We have to multiply 2x by x, so that if we divide by the LCM here, x, it will still get back, it will still get us back to 2x. So this is 2x plus 4x squared. So uh, if the LCM is x, then 2x becomes 2x squared. We have to multiply 2x by x, so that if we divide by x, we can get back the 2x. So this becomes 2x squared plus x divides x one time, so that times 42. We get 42 here, and this equals to 20. Okay, so now we can multiply both by x. So if you multiply here by x, and if we multiply the left also by x, this x divides this x, so we have 2x squared plus 42 is equal to 20x. So this is a quadratic equation, and so we can write it in standard form, which becomes 2x squared minus 20x plus 42 is equal to 0. All right, so with this, we can 2 is common to every single term, so we can divide, we can factor out 2 first. So if we do that, we have 2 times x squared minus 10x, 2 times x squared minus 10x, plus, if we factor 2 out of 42, we have 21, and this equal to 0. So we can divide both sides by 2, and if we do that, we have x squared minus 10x plus 21 is equal to 0. So we can factorize this quadratic equation. We can write 10x as negative 7x minus 3x, because the factors of 21 are 7 and 3. So we can write this as x squared minus 7x minus 3x plus 21 is equal to 0, because minus 3x minus 7x minus 3x is the same as 10x. So this becomes, we can factor x out of this, and we can factor negative 3 out of the third and fourth terms. So this becomes x times x minus 7. We can factor negative 3 out of the third and fourth. That becomes x minus 7 is equal to 0. So we have x minus 7 factored out, and x minus 3 equal to 0. All right, so let's continue on the next page. So we have either x minus 3 is equal to 0, which implies x is equal to 3, or x minus 7 is equal to 0, which implies x is equal to 7. All right, so we have the values we have for x is 3 and 7. So to find y, we have to back substitute this into equation 2 to find y. Back substitute into equation 2. So let's back substitute. Let's back substitute the values of x into equation y into equation 2 to find y. So from equation 2, we found out that y is equal to 21 divided by x. So when x is equal to um, when x is equal to 3, then y is equal to 21 divided by 3, which equals to 7. When x is equal to 7, then y is equal to 21 divided by 7, which equals to 3. All right, so the solutions are so the solutions are the solution set is when x is 3, y is 7, and when x is 7, y is 3. So this will be the solution uh, set. We can run a check to make sure that this indeed is correct. We were told the area is 21. The area is the length times the width, so we can see that 3 times 7 or 7 times 3 is 21. So satisfies that satisfies the area, and the perimeter was also 20. And we can see that 7 plus 7 is 14, 3 plus 3 is 6. And so when we add these two, then we get a perimeter value, which is also 20. All right, so let's look at our next example, which will be our example 4. So example 4, and it says solve the system by the substitution method. Solve the system by the substitution method. And the system we are given is x plus y. X plus y is equal to -7, and x minus 2 squared plus y plus 4 squared is equal to 13. So we have two equations. We call this our equation 1. We'll call this our equation 2. All right, so solve by the substitution method. So from equation 1, we know that if we subtract y on both sides, we'll have x is equal to -7 minus y. And so we can substitute this into the second equation. If we substitute this into the second equation, then we have, so if we substitute x is equal to negative 7 minus y into equation 2. Into equation 2, then we'll have x, which is equal to negative 7 minus 7. So we have 7 minus 7 minus 2 squared, and this plus y plus 4 squared is equal to 13. Okay, so this negative 7 minus 2 is negative 9. So we have negative 9 minus y squared plus y plus 4 squared is equal to 13. Okay, so we have this. So now we can expand the values in the parentheses. We can expand the parentheses and add up the terms to simplify. So the expansion of the first parenthesis is negative 9 minus y times negative 9 minus y, and equals negative 9 times negative 9 is 81. Negative 9 times negative y is positive 9y is plus 9y. Negative y times negative 9 is also positive 9y. Negative y times negative y is y squared. And so this is 81 plus 18y squared plus y squared. And the expansion of y plus 4 squared is y plus 4 times y plus 4 equals to y times y is y squared. Y times 4 is 4y. 4 times y is 4y. 4 times 4 is 16. So this becomes y squared plus 8y plus 16. All right, so now we can add both up and simplify. So we have 81 plus 18y squared plus y squared plus the expansion of the y plus 4 squared, which is y squared plus 8y plus 16, and all this equal to 13. So we have y squared plus y squared is 2y squared. We have, I think I made a mistake here. This was 18y, not 18y squared. Let me see. Yeah, so this is, okay, yeah, so the addition here, this was 18, this was 81 plus 9y plus 9y is 18y, not 18y squared. So let me get rid of this square there. So this is 18y here. Okay, so let's go back to this slide. So this is 18, not 18y. This 18, not 18y squared. So plus 18y plus this. All right, so we have y squared plus y squared is 2y squared. And we have 18y plus 8y, 18y plus 8y, that gives us 26y. So 2y squared plus 26y, and we have 81 plus 16, that gives us 97. So plus 97 is equal to 13. All right, so let's subtract 13 on both sides. So that gives us 2y squared plus 26y plus 84 is equal to 0. All right, so we can, 2 is common to every one of the terms, so we can factor 2 out. So that gives us y squared plus 13y plus 42 is equal to 0. And we can divide both sides by 2. So that will give us y squared plus 13y plus 42 is equal to 0. All right, so this is a quadratic equation, and we can solve by factoring. 6 times 7 is 42. 6 times 7 is 42, so we can write this as y squared plus, in place of 13, we can write 13 as 6y plus 7y plus 42 is equal to 0. Now we can factor the first and second term and the third and fourth term. So for the first and second term, we can factor y out, so it becomes y out, y plus 6. And for the second term, third and fourth term, we can factor 7 out, so it becomes plus 7 outside. We have 7 plus 6 is equal to 0. Now we can factor y plus 6 out. So we have y plus 6 and times y plus 7 is equal to 0. So this means either y plus 6 is equal to 0, which implies y is equal to negative 6, or y plus 7 is equal to 0, which implies y is equal to negative 7. All right, so we have y is equal to negative 6, y is equal to negative 7. So now let's solve for the value of x. Remember in the first equation we said, before we started with the substitution method, we said x is equal to negative 7 minus y. All right, so when y is equal to negative 7, y is equal to negative 7, x is equal to negative 7 minus negative 7. So this becomes negative 7 plus 7, and this equal to 0. So we have the other points 0 and negative 7. When x is equal to negative 6, we have x is equal to negative 7 minus negative 6. So this becomes negative 7 plus 6, which is negative 1. So we have the ordered pair, negative 1 and negative 6. So our solution set is 0, negative 7, and negative 1, and negative 6. And negative 6. This becomes our solution. All right, so let's look at another example. Example 5. and it says solve the system. Solve the system x squared plus y squared is equal to 40, and x minus 3 squared plus y squared is equal to 32. All right, so this is our equation 1, x squared plus y squared is equal to 40. Let's label it as equation 1, and x minus 3 squared plus y squared is equal to 32. We'll label it as equation 2. All right, so the easiest way to solve this would be the addition method. If we subtract equation 2 from equation 1, which is equivalent to multiplying equation 2 by -1 and adding that to equation 1. So we would say equation 2 minus equation 1, which is equivalent to multiplying equation 2 by -1 and adding to equation 1. If we do this, then we will have x minus 3 squared minus x squared, and you have y squared minus y squared. So the y squared term goes away, and so we have this equal to um, 37. I think this is 37, not 32. This is 37. We have 37 minus 40, which becomes -3. All right, so we can expand x squared minus 3 squared, which becomes x squared minus 6x plus 9, and minus x squared is equal to -3. So x squared minus x squared goes to 0, so we have minus 6x plus 9 is equal to -3. And if we subtract 9 on both sides, we have minus 6x is equal to minus 12. We can divide both sides by -6. So that means our x is equal to, our x is equal to 2. And so when x is equal to 2, let's find y. When x is equal to 2, we can substitute this into equation 1 to find y. So when x is equal to 2, equation 1 is x squared plus y squared is equal to 4. And so uh, x is equal to 2, we will have 2 squared plus y squared. um, 2 squared plus y squared is equal to 40. And so 2 squared is 4. So we'll have y squared is equal to 40 minus 4, which equals to 36. So y is equal to plus or minus square root of 36, which is equal to plus or minus 6. So when x is equal to 6, when x is equal to 6, the solutions are 2, 6, and 2, -6. All right. So this will be our solution sets. 2, 6, and 2, -6. All right, let's look at other examples. So we'll call this our example 6. This will be our C example. And it's an application problem. So this is example 6. And it says the difference between the squares. The difference between the squares of two numbers. Difference between the squares of two numbers is 3. Is 3 is 3 times is 3 times is 3 times 3 times the square of the first. 3 times the square of the first number is 3 times the square of the first number increased by the square of the second number. Uh, the difference between the squares of the two numbers is 3. Okay, so the difference between the square of the two numbers is 3. Is 3. And the next additional information we are given is 3 times 3 times the square, 3 times the square of the first, 3 times the square of the first number in 3 times the square of the square number is increased. It's increased by the square of the square of the second number. Square of the second number is 13. Find the numbers. Okay, so we are told the difference between the square of two numbers is 3. So assume number 1, the first number is x and the second number is y. So that would mean that x squared minus y squared is equal to 13. If we assume first number is y, okay, let me write that down first. If we let the first and second numbers be x and y respectively, Then x squared minus y squared is equal to 3. We are told the difference between the square of the two numbers is 3. So x squared minus y squared is 3. So this is our first equation. And we are told that 3 times the first number, so 3x, times the first number is increased by the square of the second number. So 3x plus y squared is 13. So this becomes also our second equation. So we have these two equations to solve. And so we can see that in the first equation, we have minus y squared. In the second equation, we have positive y squared. So the easiest way would be to use the addition method. So if we add equation 1 to equation 2, we're going to have 4x squared and minus y squared plus y squared is equal to 0. So 4x squared is equal to 16. And if we divide both sides by 4, we divide both sides by 4, we have x squared is equal to 4, which means x is equal to plus or minus 2. All right, so let's find the values of y on the next page. So x is equal to plus or minus, so we can substitute this value, the value of x into any of the equation, either equation 1 or 2, to find the value of y. So when x is equal to positive 2, let's substitute this into equation 1. Equation 1 is x squared minus y squared is equal to 3. So when x is equal to 2, we'll have 2 squared minus y squared is equal to 3. And so this becomes 4 minus y squared is equal to 3. And so if we uh, subtract 4, um, we can either subtract 4 on both sides. That will be minus y squared is equal to negative 4 plus 3, which equals to negative 1. And so now we can divide both sides also by negative 1. So we'll have y squared is equal to 1, which implies y is equal to plus or minus square root of 1, which is equal to plus or minus 1. So when x is equal to 2, we have 2 and positive 1, and also 2 and negative 1 as solutions to the equation. And when x is equal to negative 2, when x is equal to negative 2, we have x squared minus y squared is equal to 3 again. So we have negative 2 squared minus y squared is equal to 3. Negative 2 squared is 4, so 4 minus y squared is equal to 3. So that means minus y squared is equal to 3 minus 4, which is equal to negative 1. And if we divide both sides by negative 1, we have y squared is equal to 1, which implies if we take square root on both sides, y will be equal to plus or minus square root of 1, which is equal to plus or minus 1. So when x is equal to negative 2, we have the solutions as the solutions that will end up when x is equal to -2 is -2, +1, and -2 and -1. So these become the four solutions that we have. Okay, so um, let's look at another example that says we have to solve the system. And we have to solve the system. This is example 7. We have to solve the system. Y is equal to 4 plus x, and um, no, let me write this as we have to solve the system. Y minus x is equal to 4, and the second equation is y is equal to x cubed plus 4x squared. So we have two equations, and we have to solve these equations. Okay, so from equation 1, we can write it as y is equal to 4 plus x. And from equation 2, it's also giving us y is equal to x squared plus 4x squared. So in place of y here, we can write, in place of y in equation 2, we can substitute 4 plus x in its place. So if we do that, we'll have 4 plus x is equal to x cubed plus 4x squared. And so um, we can so we have 4 plus x is equal to x cubed plus 4x squared, x cubed plus 4x squared. So here we can factor, let's group all the terms on one side and factor x and factor some variables out. So here we have x cubed plus 4x squared minus x minus 4 is equal to 0. So we can factorize x squared out of the first two terms. So we have x squared times x plus 4. We can factorize minus 1 out of the second parenthesis. So minus x plus 4 is equal to 0. Now we have x plus 4, x plus 4, so we can factorize x plus 4 out. So x plus 4 times x squared minus 1 is equal to 0. So from here, either x plus 4 is equal to 0, which implies x is equal to -4, or x squared minus 1 is equal to 0, which implies x squared is equal to 1, which means x is equal to plus or minus square root of 1, which gives us plus or minus 1. All right, so we can substitute. So we have three values of x, -4, +1, and -1. So we can substitute each of these values to find the corresponding y value. So our first equation, we said y is equal to uh, 4 plus x. So when x is equal to negative 4, when x is equal to negative 4, like we found, when x is equal to negative 4, like we found, we will have um, y is equal to 4 minus 4 equal to 0. So we have the solution set negative 4 and 0. When x is equal to 1, we have y is equal to 4 minus 1, which is equal to 3. So we have the solution as 1 and 3. And when x is equal to negative 1, we have y is equal to 4 minus negative 1, which is equals to 4 plus 1, which is equal to 5. So we have the solution set negative 1 and 5. So this becomes all the solution sets that we have for this particular last example. So we're going to end here and we will continue next time. Bye bye.